Here we're going to be looking at some properties of logarithms, and this applies for logarithms with, again, the base must be greater than 0 and a can't be 1. So if we have log base a of a, it will always equal 1. And the reason for that is, if you think about it, a to the 1 power will always equal a. So if I have log base 3 of 3, it has to equal 1 because 3 to the 1 gives me back 3. And it wouldn't matter what these were. It could be log base 5 of 5, log base 27 of 27. They're always going to equal 1. Same holds true here. Log base a, and it doesn't matter what the base is as long as it's greater than 0, log base a of 1 equals 0 because any number to the 0 power will always equal 1. So log base 10 of 1, log base 3 of 1, log base 27 of 1, it's automatically going to equal 0. Log base a of a to the x will automatically equal x. And if we think about that for any real number x, if I have log base 7 of 7 cubed, it has to equal the number 3 because 7 to the power 3 has to equal what's inside here, 7 cubed. And that works for any power. So log base 7 of 7 to the 5th will automatically be 5. Or think about log base 2 of 2 to the 4th will automatically have to equal the number 4. It's like these cancel out and you're just left with what the power is equal to. Similarly, a raised to the log base a of x will equal x. So if I have 3 raised to the power log base 3 of 7, what this says is if these bases are the same, everybody cancels, and the answer is equal to the number 7. So these are the general properties of logarithms. There are two specific types of logarithms that we're going to be looking at. One is called the common logarithm. The common logarithm is the one that has base 10. And normally, you don't even see the number 10 down there. It's just assumed to be 10 if it's not written in. The other type of logarithm is called the natural logarithm, and its base is e. Rather than write log base e, we're going to shorten it to ln, representing natural log, but its base is e. If you take a look on your calculator, this will kind of help you out a little bit. If I look at the word log on my calculator, right above it is 10 to the x. The base being 10 on the exponent is the base on the log when I don't see the base. And right above the ln is e. So the base of a natural log is e. They have the same properties as the log properties that I saw above. So for example, this is really saying log base 10 of, and then the argument is 10 to the 1, or 10 equals 1 rather, because 10 to the 1 power gives me back 10. This one is natural log of e equals 1. So another name for natural log is log base e. My argument is e equals 1. All right, that goes back to this property up here. Log base a of a equals 1. That's what these two are saying here. So log base 10 of 1 equals 0 is following along with this property right here. It's just that if it's not shown, you can squeeze in a little baby 10 here to remind yourself that that's base 10. Here's another base 10 if it's not written in. So log base 10 of 10 to the x equals x. Log base 10 of 10 to the 5th automatically going to equal 5. Because again, the base here is 10 if it's not written in. Same with the natural logs. These are ln is short for log base e, and then my argument is still e to the x. And that's just equal to x. Right. And then these follow the same property as here. If these bases are the same, everybody cancels, and I'm left with just the argument. So for down here, the logarithm has a base of 10. These are all going to cancel out, and I'm left with just the argument. Same thing here. This is e raised to the log base e of x. Everybody cancels. I'm left with just x. So for example 31, without using your calculator, you should be able to use the properties above to answer these. So this is log, the base is missing, so it's base 10 of 10 to the 12 just equals 12. All right, let's jump over here to D. This is e raised to the natural log, so we think to ourselves that's log base e of 17. And again, that follows this property right down here, letter D. Cancels out, I'm left with 17. You don't really even need to write this intermediate step in if you refer back to this property right here. So 10 log base raised to the log base 10 of 825 is 825. Again, that's following this property right here. No work to show. Don't even need your calculator. For letter E, again, this is log base 10 of 10,000. So we've got 1, 2, 3, 4 zeros here. So this could be rewritten as log base 10 of 10 to the 4th power. So our final answer then is going to be just 4. Right. For this one, log base e of e to the 6th is just going to be the number 6. Log base 5 of, now that's not 5, so I need to rewrite 25 as 5 to a power. So log base 5 of 5 squared. And then again, it follows right along with my property here, letter C. Log base something of something to the x. Log base 5 of 5 to the 2. Just going to equal the number 2.